Well, hey everybody, how are we doing today? We are getting ready to solve absolute value equations. This is going to take a lot of the information that we learned all from chapter 1 on solving equations and now start to apply it to one of our first parent functions we're about to learn. So again, parent functions. A parent function is what our equations look like in its most simplest grafted form, meaning like here's the function, the absolute value of x. Okay, simplest thing. Notice there are no numbers. There's nothing in here. Okay, nothing is in there. So when you go to plug in x values, like when x equals 0, the absolute value of 0 is 0. So that's the coordinate 0, 0. And then if you plug in 1, the absolute value of 1 is 1, so that's the coordinate 1, 1. The absolute value of -1. Well, what happens with an absolute value? It gobbles up the negative and only produces a positive number. So that would be -1, 1 as a coordinate. And that's how we slowly start to build these coordinates here. -1, 1, 1, 1. Plug in a 2, our 2's come in, and so forth, and so on. 3 would be 3, -3 would be a positive 3, and so on and so on and so on. So basically anything you put in becomes positive in its output. So we could sometimes have like two numbers. Like look here, if the absolute value of x equals 3, well, x could be 3. It also could be a -3. So we have to always think about that and take that into account. And of course, we can't always represent these solutions on a number line. You can have a number line and you can put your solution on the number line here. So if this is your number line, we have a -3, +3. These would be solid dots at -3. It could be a solid dot at a +3, because those could possibly be the solution to this. Now, of course, it's not always going to be as simple as this, where it's in its base form, its parent function form. Most of the time, we're going to end up having equations that have all the other numbers that are added into it. They're being added on the inside of the absolute value. They're being added on the outside, or maybe they're multiplying an absolute value by something, and we need to be able to solve them. So we have 3 steps to solving an absolute value equation. That's what AVE stands for, absolute value equation. First off, we want to isolate the absolute value, those bars. We want this here to be all by itself. Notice it's not. We have an extra piece over here. We have a +3. So just like we were doing with our equations before, this line just a little bit bigger. It's the same thing. We have our scales, right? And I can't touch the absolute value. So what I can move though is that +3. How do we remove a +3 from one side of the equal sign and move it together? We subtract 3. And if we do it to one side, we can do it to the other, right? So 8 minus 3 leaves us with 5. And now we have the absolute value of x plus 2 is equal to 5. Step 1 is done. We've isolated our absolute value. Now we need to break it into 2 equations, one with a positive solution, one with a negative solution. So draw a little line. You're going to use your expression in the absolute value bars 2 times. You're going to have an x plus 2 equals 5. And then we use it a second time. X plus 2 equals, this time it's -5, or the opposite of whatever's on this side of the equal sign. All right, here's one positive possible answer, one positive possible negative answer. And then we solve each one. So again, this is a nice, easy equation, right? One-step equation. We're going to subtract 2. And I always like drawing little scales, so I remember what I'm doing. These cancel, and we're left with an x is equal to 5 minus 2 is 3. And we have to do it again. Subtract 2. I'm going to subtract 2. Right, these cancel, and so we have x is equal to -7. And like that, we have our possible answers, right? Think about this. We can actually test this work. If I take this 3 and I plug it in, right? 3 plus 2 is 5. Absolute value of a +5 is +5. Add 3 to it, you get 8. You could also do the negative, right? -7 plus 2 is -5. Absolute value of -5 is a +5. Add 3 to it, we get 8. So we know that both of those answers work. If you wanted to put it on a number line, just to see, well, -7 would be over here. We have a +3 is over here. And of course, only those two, those are the only two numbers that make it true. So there's solid dots at those numbers. All right, now we have to just keep solving. We have a few more examples to do today. Let's look at this. This one doesn't have any work. Remember, our first step was isolate the absolute value. It's already isolated. All right, so that means we can split it in two. X equals 7. We reuse the information in the middle again. X equals, and this time you take the opposite of what's on that side of the equal sign, -7. Like that, you have two answers. Your answers solutions are, we can do it in a solution set, -7, comma, 7. Two solutions. When we separate our answers using a comma in Delta Math, that's what it does. It opens up those solution sets. Here's example 3 again. Is our absolute value isolated? Is there a number being multiplied outside? No. Anything being added on this side? Nope. We are ready to split our equation. We have 8x equals 24. And then we have an 8x equals -24. And we are ready to start solving that down, right? So again, this is a fairly easy one. We don't have to do much. These are being multiplied. How do we get rid of the 8? We divide by 8. If I divide one side by 8, I have to do both. And we get what? X equals 3. Do it again. And x equals -3. Please don't think that you're always going to get these results where it's like, 7 and -7, 3 and -3. It doesn't always work that way, okay? Especially when we have more happening. When there's more than one term inside of these absolute values, it generally doesn't happen that way, okay? And we'll see that in our next couple of examples. Again, if you want, you can put these numbers on a number line. That just depends on if your book or your program asks for that, so be careful. So as we go through here, now we look. Here's another one, right? Look, isolate. Step 1, isolate your absolute value. There is nothing here for you to do, so all we have to do is split it. So ready to go. X plus 2 is equal to 3. Again, we're going to reuse that x plus 2 on this side is equal to -3. And then we solve. So we subtract 2. Here we have an x is equal to 1. Here we subtract 2. Both sides of our equation. So x is equal to -5. And like that, you have your two solutions. Notice they're not the same as they were before, right? We don't have a positive and a negative of the same number because there were more than one term inside of this absolute value. That's what happens. Keep going here. Oh, notice what's different with this one. This is a little different, right? Oh, it's set up backwards. It's okay. Nothing changes. Here's your absolute value. You're supposed to isolate for it. So again, to isolate the absolute value, we need to get rid of this -3. So we'll add 3. Those cancel. And we're left with a 5 is equal to absolute value of x plus 2. And we are ready to split it up. So we can have 5 is equal to x plus 2, or -5 is equal to x plus 2. All we do here, same thing. It's just solving equations like we've been doing for all these chapters. Subtract 2 from both sides of your equal sign. So one side is 3, subtract 2. Notice, see, we're subtracting 2 negatives, so we get a bigger negative. No big deal. Our solutions are 3 and -7. Now this one is the largest of all the problems that we have. Notice we have something being multiplied outside. We have something being added or subtracted on this side. So this will take a few steps to isolate that absolute value. First thing is first, we need to get rid of the addition because this is all trapped. This whole thing is trapped by multiplication right here. First, get rid of the 6. So you're going to subtract 6 from both sides. Leaves us with a 12. All right, then what do we do next? Bring down everything else we didn't use. Be careful too. Look, they changed our variable. Now we divide by 4. Okay, this goes away. This becomes a 3. And we're left with the absolute value of 3w minus 2. All right, split it and solve. 3w minus 2. Oops, we ran out of room, equals 3. It's really crammed in there. 3w minus 2 equals -3. All right, we add 2 to both sides. 5 is equal to 3w, and you divide by 3. So one solution is 5 over 3. Just leave it like this. This is a fully reduced fraction. You're cool. I'm going to add 2. With a -1 is equal to 3w. Again, divide by 3. And there's another reduced fraction, -1 over 3. Totally fine to get fractions. So those are your answers there, 5 over 3 and -1 over 3. Like that, guys, this isn't that hard because we've been solving equations for weeks. We know how to do this. The hard part, the new part, is isolating this absolute value and then making sure that you split it into 2, one with a positive solution, one with a negative solution, and then you solve. All right, guys, that's it. Get out there, do your homework, and finish everything up. Have a wonderful day.